So this is the movie made for reviewer number 3. I would like to show you our laboratory. Here is some measurement equipment. Here is a conveyor working in vertical direction. That's a conveyor working on a Fram eliminator. We are talking about that in the article. This is a classic conveyor. How does it work? We have two masses, vibrating masses here, two electrovibrators giving a force down this line, which causes the throat to vibrate and to transport from the left side to the right side anything you put on it. Yeah. Here is a conveyor working in a resonance zone, and the resonator is inside this mass here, but it's hard to see, so I'm not going to show you how it works. I will show you another one. This is a very classic conveyor where you have two masses which give a force down this line, of course, when they are synchronized, and this will vibrate in this direction, and when we put something inside here, it's going to be transported from left to right. This type of a conveyor, if you take into account that the first resonance zone is a combined resonance of X, Y, and the rotation of the main mass, then we have one resonance on the beginning, and then we come to the working point. This is how it looks like. Here you have the amplitude on the Y axis, and on the X we have omega, yeah? And this is our working point. So it comes to the working point. This type of a conveyor is usually used in all the factories, but first of all, we have to use a big vibrator, and the second thing is very hard to dose with it, because when we go down with our rotation velocity, we enter the resonance zone, so it's very hard to control dosing of this type of a conveyor. Another type of a conveyor is a conveyor working in the resonance zone, and this is the one I'm going to show you, that it's working and that it's stable. This is a conveyor made by my PhD student. It's my patent, and it works in a way that there is a force generated in this. There is only one vibrator, so there is no synchronization here, and the force is generated in this planar. Theoretically, it should not transport, but the force is very small, because as you can see here, this is set only to 10% of the maximum force of this type of electrovibrator. And when it goes on this direction, there are two masses that are combined together, and there is no suspension on this direction, so the amplitude on this direction will be very small. On this direction, they're on this suspension, and on this direction, they will be working in the resonance zone. This is a resonator of this mass, and this will help add the amplitude. This is different from the one that we are analyzing in the paper. There, the vibrator is connected to the resonator, and this is a more popular one, but there are no articles about this type of a conveyor we're analyzing in the paper. That's why we did it. How does this one work? On this direction, we have two resonance zones. First one is the main zone, combined of X, Y, and the rotation, and the second is mainly depending on this mass, and this stiffness of this suspension is between these two masses. So if we look at the characteristic, it looks like this. We have the first resonance zone on the left, then it goes up to 0, so it stops completely the vibrations, and then we come to the working point, which is this point. This is our working point, and this is then the resonator is also vibrating, yeah? So we are working in the resonance zone to get transport. I'll show you how it works, and I'll show you that it works very stable. Of course, there's no control system in this one. The control system, it's me right now. Here you have how it will start. It will start at this. When you divide this by 2, it's the rotation velocity in hertz. When you start it, you can see that the material will be transported when it comes to the point. The material is transported. When I want to stop the transport of the material, I just go down with the rotation velocity just a bit, as you can see, and the transport nearly stops. Or you can completely stop it, yeah, if you want to stop it. You can go back to the transport, and then you can stop it. But what you heard is the bumper that was hit because I entered the resonance zone too far. As you can see, this works. Why did we do the article? Because that type of conveyor, which we are analyzing, is very popular, but there are no articles about this, and there is no equations that allow to project this type of conveyors, to have the dependencies between the working point and all the stiffnesses and the masses of this conveyor. And this is what we showed in this article, and we show how to do it, and we analyze, and we also found out, and we showed that putting this mass bigger, it's better. it doesn't make any difference. You can use a small vibrator. This vibrator here, if this conveyor would be working as a classic conveyor, you would have to set it for 100% of the force. This is a laboratory conveyor, that's why we put a big vibrator, so we can do it in 2 ways. But normally, if you would build a conveyor like this, you would use a very small vibrator. Thank you for listening. I hope now you can see that it's easier to see that it's working stable in resonance zone than to read it. So that's why we showed this movie for you. Thank you, and thank you for the review once more. Bye-bye.